All right. Thank you guys for being here. This is the culmination of about 3 years' work, 2 field season, lots of help from technicians and refuge biologists, managers, and friends and family. So I'm really excited to finally be here to share all of this with you guys. Snowy plovers are a small, relatively rare shorebird found in North, Central, and South America. And currently there are 3 subspecies recognized. I work with Schroderius novosus, which makes up the majority of snowy plovers in North America. Globally, they are listed as near threatened by IUCN, and federally, they have a threatened status on the Pacific coast only. On the state level, they're listed anywhere from critically imperiled to vulnerable. In Texas, New Mexico, and Oklahoma, they're either imperiled in New Mexico or listed as vulnerable. You find snowy plovers on sandy coastal beaches, like this one on the bottom your left. But you also find them on some really unique inland habitat. This is a alkaline salt flat in Oklahoma. This is the shorelines of a saline lake in Texas. And on the Southern Great Plains, a paucity of data exists. So not a lot of research is done in this area, especially compared to their coastal counterparts, in part because they're not listed as federally threatened here. They also don't encounter people as much. They're not on these densely inhabited coastal beaches, so they don't get a lot of attention. But across the range, they are widely distributed here, and they exist on these really isolated, discrete habitat patches, anywhere from 15 kilometers apart to 600 kilometers apart. And across the range here, they've been threatened by habitat degradation. So you have increased rates of nest predation. We've got documented decreased survival. And we also have, and I think it's really important here, especially in Texas and New Mexico, this loss of reliable surface water. So on the high plains of Texas and the Panhandle, historically 40 saline lakes have been fed by freshwater artesian springs from the Ogallala Aquifer. And over the past half century, as some of you probably know, the Ogallala has been severely depleted by intense agricultural activities in this area. And as a result of this, these saline lakes are drying up. And currently, less than 10 have active springs now. And snowy plovers need these springs to thermoregulate. They soak their feathered bellies, and incubate, keep their eggs cool, keep themselves cool. And they also need it for habitat for their food sources. So you can kind of see the edges of this bottom left spring has brine flies, little black dots, and those are a big staple of snowy plovers. And without water, you don't have those. The justification for my research here kind of began about 10 years ago with this study showing upwards of 75% declines in snowy plover abundance in Texas, which is a big red flag and is a big impetus for why I'm doing this. There's also, again, a scarcity of research in this region. We don't know the population connectivity of snowy plovers in this region. We don't know where they're moving and when and who's moving. And just generally, a population assessment is needed on the Southern Great Plains, I think, to help determine population changes over time and to provide insight for researchers with the goal of more efficient and effective conservation management in light of these declines. Specifically, my objectives were to investigate 20-year population trends. So 10 years ago, we had declines, and I wanted to know what's happening now. Are they increasing, decreasing, holding steady? I also wanted to look at density and population size, specifically at a very large population in Oklahoma at Salt Plains National Wildlife Refuge, using distance sampling or detection probability. And lastly, again, I wanted to look at population connectivity on the Southern Great Plains of snowy plovers, see who's moving where and when. My study sites were Salt Plains National Wildlife Refuge up in north central Oklahoma, Muleshoe National Wildlife Refuge in Texas, and Bitter Lake National Wildlife Refuge in New Mexico, right outside of Roswell. And I also had 3 privately owned saline lakes that I designated A, B, and C to protect landowner privacy. I have 2 chapters I'm going to talk about today: population trends and population connectivity. I'm going to go through methods, analysis, and results of those each in turn. And then at the end, I'm going to talk about conclusions and discussion all together. So to start with population trends, my data sources, we had 3 data sources. We had these Texas surveys. We had Bitter Lake surveys done by the refuge. These were driving transects and point surveys. And we also had 2 different kinds of surveys done at Salt Plains in Oklahoma. We had annual surveys conducted by the refuge, and we had these distance sampling surveys that I and my technicians conducted in 2017 and 2018 during the breeding season. So lots of methods about to come at you. So in Texas, these were from 1998 to 2018, sporadically. These were weekly surveys done during the breeding season through May through July. They were roughly 3.5-kilometer transects that you can see in yellow there. These were at the 3 privately owned saline lakes. We counted adults and juveniles and recorded any uniquely marked individuals. So we color band these guys so that we can identify them from a distance. At Bitter Lake, these were conducted by the refuge. These were done from 1999 to 2018. These were bi-weekly year-round surveys, driving surveys, survey points done by multiple trained observers. And essentially, all the plovers were counted up in these little green wetland units and totaled across the entire refuge. At Oklahoma, again, there are 2 different kinds of surveys done here. The first I'm going to talk about is these annual population estimate surveys done from 2013 to 2017. So done once a year in that time period. And these were designed by the refuge biologist. And the salt flats, which is where you find snowy plovers, was delineated into these grid cells. There's 668 grid cells total. Each is 300 by 300 meters squared, or 9 hectares. And each year, 100 random cells were chosen and divvied up between groups of 2 observers. And each group was given 10 to 12 surveys each, roughly. And one morning and early afternoon in May, we all went out and surveyed all these blue grid cells. For a distance sampling, again, I used these same grid cells. These were done in 2017 and 2018 from June to July. They were weekly surveys. And the big difference here is that because you can't get across the entire flats very easily. You have to ride ATVs. And there's this big stream right in the middle that you can't really cross in an ATV. Anyway, we had to separate the flats into regions, essentially. And I randomly chose grid cells within those regions to sample weekly, and all these surveys were done in a day. Again, north, middle, and south regions, and there were 75 grid cells in each region. Now, to do a survey at Salt Plains, whether it's distance sampling or regular population estimates, 2 observers stand on the north side of these grid cells, 150 meters apart, and walk due south at approximately the same time, and count all the snowy plovers within 75 meters of either side of them. Taking care not to count the same plovers, which takes coordination before, during, and after the survey. And when distance sampling, we also estimated the bird's distance from the transect. So these weren't done, the distance sampling wasn't done during the annual population surveys, just for the distance sampling surveys. To analyze these data for population trends, Texas and New Mexico data were over-dispersed count data. So the variance is greater than the mean, and I had to use a negative binomial regression to model them. I used May through July data only, and I omitted Lake C because Lake C wasn't surveyed until 2008, and it wasn't surveyed every year after that, so I just left it out. In Oklahoma, I use these population estimates. There's only 5 of them, so it's a small sample size, but I use simple linear regression to model them. So it's not a robust analysis, but that's what I did. For distance sampling, I used AIC model selection in program distance and a conventional distance sampling analysis engine to create these global and stratum or region estimates. So the global is those 3 regions put together. And I also got separate region estimates. And on to results. So in Texas, at lakes A, B, and C, you can kind of see a visual pattern of decline of snowy plovers in the past 20 years. So this starts in 1998 and ends in 2018 and was surveyed sporadically throughout. These are mean survey counts with standard error bars. And I think this is better at showing sort of the natural fluctuation in abundance of plovers. But I wanted to point out here that in the last 10 years, we had an increase in 2010 and 2017 in abundance that actually buffered those declines. And so we didn't have that sharp decrease continue. But I will point out that between 2017 and 2018, Lake A decreased by half, and Lake B also decreased. Lake C has decreased since 2010. So, you know, declines aren't as severe, but they're still occurring. Again, in Texas, so this is the results of my regression. And from predicted observations, I calculated a roughly 45% decline since 1998. But the past 10 years, we have no significant changes. If anything, kind of a slight increase. In New Mexico, we have an almost clearer visual pattern of decline in the past 20 years. This is a much finer scale. You can really see these fluctuations happening. These are mean survey counts with standard error bars. And again, these are made through July data only. But you know, we have a lot of fluctuations from year to year. And I think particularly in 2007 is really when populations here, I think, gotten a lot of trouble. They haven't been able to recover so much since then. The results of my regression show 60% decline since 1999. The last 10 years, I didn't put it up here, but it's a 30% decline. So slowed a little bit maybe, but overall we've got sharp declines in the past 20 years. For population estimates in salt plains, we don't have any significant changes over the period these annual surveys were done. Again, this isn't a robust estimate, but we have an average of 4,500 individuals. And I wanted to point out that in 2007, Thomas et al. Estimated the population at Salt Plains to be about 5,200 individuals. So I feel comfortable saying that in the past decade, Salt Plains populations have held relatively steady, especially when compared to Texas and New Mexico. For my distance sampling results, I had a really high detection probability of 1. So to me, this says that you're equally likely to see a plover 10 meters away as you are 60 meters away. And this can mean a couple of things to me. First of all, high detectability of plovers. This is supported by some literature on the Southern Great Plains at Salt Plains and in Texas. And it really, I think, validates those annual surveys that those observers were seeing snowy plovers. They weren't missing that many. Also, I think this kind of minimizes observer bias. So if you have a really experienced observer, a less experienced observer, this high detectability will help minimize the effects of that. And this is not too surprising when you have a landscape like this. Snowy plovers are cryptic in coloring, but they're actually pretty conspicuous in behavior. So they call out, they do broken wing displays. They let you know they're there. So. For my density and population estimates, I got a really high density estimate of 2 individuals per hectare, which each of those grid cells is 9 hectares. So to give you a kind of perspective, and a population estimate of 4,200 individuals. And I think what may have happened is sampling bias. I sampled high quality or high dense habitats, which might have resulted in this high density. So in the future, methods could be adjusted, I think. For chapter 2, connectivity, I looked at the movements of snowy plovers. I wanted to know, again, who went where and when across the southern Great Plains. And also I got this sort of bonus look at migration departures, which I wasn't expecting going into this study, but it was kind of fun to look at these data. So I looked at timing of departures, so what time of the day these birds were leaving, and what date they were leaving, so what time during the season. To monitor movements of snowy plovers, I use the MODIS wildlife tracking system, and this is an array of automated telemetry towers that are isolated, and they can scan, detect, and record constantly the signals from coded avian nanotag transmitters. So these little transmitters are tiny, and they give off bursts of signal every 10 seconds or so. And within this signal is a unique identifier for that tag. I call it a barcode, essentially. And these towers and the software involved can tell the difference between the tags using that barcode. And we were able to look at breeding season movements between these local lakes and actually movements to the coast. And I integrated some capture, mark, recite data. So again, we color band these individuals, and we did some resites at other lakes. So we detected movements that way. And again, we also detected some birds migrating that way. So the MODIS wildlife tracking system is global. Each of these yellow dots is a telemetry tower. It's a group of a lot of different researchers putting these towers up for a lot of different reasons. This is where it started, which is why there's so many in the sort of Great Lakes region. But I wanted to point out all these towers on the coast. There's anywhere from 15 to 25 towers. It changes all the time because researchers put them up and take them down. But using these towers here, we can monitor their movements to the coast if they migrate to the coast during the winter. To start off, we put up a telemetry tower, one at each of my 6 field sites. This took roughly 6 months to a year to do all of this. This is a picture of a rare picture of the elusive Dr. Conway and Dr. Bull putting this tower up, and Chris Carter supervising. And once the tower is put up, it looks something like this. These are 30-meter towers. They're topped by either 5-element Yagi antennas, like the ones in this picture, or 9-element Yagi antennas. And I'll talk a little more about the difference between those two in a second. They're powered by 100-watt solar panels that charge a 12-volt car battery, essentially, which in turn powers all the components in what is collectively known as a sensor gnome. And this little computer here is what is scanning and recording for detections. This is called a BeagleBone. And these little receivers here are FunCube dongles. So the vernacular is pretty fun. Snowy plovers nest on the ground, so we catch them on the ground at their nests. Their nests look like this. We use bow nets to do this. Snowy plovers have a really strong compulsion to incubate. It's hot out there. They want to cover those eggs. So they ignore this big snake-like object that just appeared next to their nest and sit on them anyway. We pull a pin from a string. We're kind of far off. And the bow net closes over them. And we go and safely extract them and process them. So we take morphometric data, we weigh them, we take pictures, we band them, of course. And then we put on these little transmitters. So this is called a figure-8 leg loop harness that I designed using a design from another project. But these are made out of cotton sewing elastic. So they're stretchy, they're soft. We tied them together, and there's a little square of foam that sits between the bird and the transmitter to help buffer any chafing or anything like that. And collectively, these weigh about 1.5 grams. But you put them over their legs, and it sits on their the base of their tail right here, and the antenna shoots out, is kind of flush with their tail, and they're able to fly, forage, incubate. They've even come back from migration, so it appears not to bother them much, at least. To analyze movement data. So the biggest problem here was filtering out what are called false detections. And we wanted to be very conservative because I didn't want to say a bird was at a tower when it wasn't. Because these birds were popping up in towers in Panama and South America and Barbados and really cool potential areas, but I couldn't confirm those. I had to be very conservative and take those out. They were showing up everywhere in Pennsylvania. What's happening is all these towers in the network are being bombarded by, radio frequencies constantly, electromagnetic waves from machinery, airplanes, all kinds of stuff. So noisy towers are ones that are in noisy areas. And every once in a while, by chance, they actually will pick up a combination of frequency that sounds like a tag. And noisy towers just do that more often and pick up tags. Noisy tags have frequencies that just get picked up more often on any tower. So this was a noisy tag. This is receiver latitude on the left here. So it's 50 degrees latitude all the way to 10. So this is like Great Lakes, Canada to, Central South America. So this bird did not do this. Okay, this was a red flag. So I ended up taking this tag out completely, even though some of these detections were probably true. This is an example of a noisy tower. I think this might have been the one in Pennsylvania that just picked up all my tags constantly. So I just took that one out. This is another tag in South America that got picked up all my towers for tags, a whole bunch. So anyway, that was actually a lot of work, and I had to be very, go through it with a fine-tooth comb. To analyze departure date, what I did was I used this date of last detection as a proxy for the date of departure. So I don't know for certain that bird was leaving on migration, but I used birds that were only consistently detected at a tower and then disappeared. I also excluded any birds that were only detected 1 to 2 times at a tower to make it a little more certain or accurate that these birds were actually leaving on migration. I used two-way ANOVA to compare sex and site of these ordinal departure dates. So when I say ordinal, I mean number of days since January 1 of that year. And I used a logistic regression to model some weather covariates against the occurrence of departure. The regression, the covariates I used were photo period, wind speed, temperature, relative humidity, and 24-hour percent temperature change. And these are some covariates that other studies have used, which is one of the reasons I included them. I used data from the National Weather Service, their automated surface observing system, and I correlated the sites of departure to their closest weather station, which turned out to be airports in all cases. I used this window of May 11th to September 30th, and I used a zero inflated Poisson distribution to model them. For departure timing, because time is a circular data, it's not constant, I use directional statistics to analyze them. So I got mean departure time using that. I also compared departure times by sex and site using the Rayleigh test of uniformity, which again is directional statistics, to see if there's any unimodal directionality, which is a fancy way of saying, are they leaving at a significant time during the day, or are they leaving randomly throughout the day? I also used a Watson 2-sample test of homogeneity to determine if two samples were the same, they're leaving at the same time or different times. For my results, overall, in 2 years, I caught 216 adults. I tagged 119 birds. I say me, my technicians and I. 108 tags were detected at least once. And overall, 21 plovers, or 19% of this 108 detected tags, made at least one movement between towers. And this is local movements or migration movements. In total, 40 movements were made. And this figure here is just a breakup of male and female, and generally males made up 20% of all of these metrics here. The movements, regional movements and migration movements all together look like this. So we had the only migration movements we detected really were from Salt Plains to the Texas coast here. And lots of movements between Texas lakes, which you can't see here, but I'll show you in a second in a different way. And we did get some movements between Bitter Lake to Texas lakes. I'm not going to show you every movement made, but I'm going to give you some examples of birds making movements. This is latitude on the left here. And this bird was at Lake B. I mixed these up apparently. This bird was at Lake B and it moved to Lake A. And on these figures, you can see where the towers are actually. And the closer a bird is to a tower, the better it's detected generally. This is another way of looking at a movement. So this is actually the same bird. This is signal strength. Each color of one of these dots indicates which antenna on that tower it's being detected on. It's kind of interesting. You can see sort of the daily activity of a plover when they're detected constantly like that. So these dips here are nighttime. So this bird moved from Lake B to Lake A. And this tower was actually had 9 element Yagis on it, and they're not as good at detecting birds on the ground, turns out. So this is why you only have one antenna detecting them as opposed to all 3. We actually changed that after 2017. We put 5 elements on instead of 9 elements. This bird was at Lake C. So this bird is at Lake C. You can see flights. These are just flights that are being picked up on a tower. And this tower was up here on the north, and the active springs were down here on the south. This is as close as we could get to them. So that's why you're not getting the detail as you are as Lake B. The active springs at Lake B are right around that tower. So this bird made a movement around July 9th. This is a migration movement. So we have a flight here at Salt Plains. This bird was flying by this tower. Roughly 12 hours later, it showed up at San Bernardino National Wildlife Refuge on the coast. This was 871 kilometers, and if it flew from tower to tower, it took roughly 62 kilometers per hour. And to my knowledge, no one's really determined the flight speed of a migrating snowy plover yet. So this was kind of cool. When looking at movements, especially regionally, it was kind of hard to show you guys what movements were made to any degree of clarity. So I made this sort of representational map to do it a little better. We've got Oklahoma here at the top, Texas in the middle, New Mexico here down, near the bottom, and wintering grounds on the very bottom. And each star indicates a site. We had a lot of movements between Texas lakes. Roughly, I've lost the number, but 30 to 40 movements between these lakes here. So high connectivity. We had some movements between Bitter Lake and Texas lakes. We had one bird from Bitter Lake fly to Lake B and back under 8 hours. And interestingly enough, if it flew tower to tower, it also flew 62 kilometers per hour. So kind of a coincidence, I think. But one bird flew to actually Lake C was detected for a little bit and then disappeared. So I don't know if that was a migration movement, where it went afterwards, but it did fly to a Texas lake. We had no connectivity between Salt Plains and Bitter Lake at all. We also had no connectivity to Muleshoe. No birds on my study were detected at Muleshoe. And my theory is that Muleshoe, the springs there are almost non-existent, and it relies primarily on precipitation runoff for water inundation. And whenever I went there, I was not seeing plovers, especially during the breeding season. You'll see them in the beginning, but once that water dries up, they disappear. So this is not habitat that they are selecting for. We had lots of movements, again, between Salt Plains and the Texas Gulf of Mexico, and also Louisiana Gulf. And we had one bird move from Salt Plains and briefly detected at Lake A. And because of the time of the season and because it was briefly detected, I think this was a migration movement that it flew near Lake A but didn't actually land there. So maybe weak connectivity there, but I would lean on the side of no, because it was just a brief flyby moment. And we have no idea where Bitter Lake birds winter. We didn't detect them on any of our Gulf Coast towers, so their wintering grounds still remain a mystery. We also don't have any reed sites. Overall, 53.8% of all detected movements were to Lake B. And this, Lake B is in the middle, right? But it may also constitute some higher quality habitat potentially. Its tower was a little better at detecting plovers. So there's some other nuanced things going on there, but primarily these movements were made to Lake B and to Lake C. A lot of these movements were made by a couple of individuals only. 2 females made a good majority, like 30 and 40% of these movements. For departure time, so this is when they left on departure for migration during the day. This red arrow here is the circular mean of departure. And on average, they significantly left at 2100 hours or 9 o'clock in the evening, which may indicate that these birds are actually nocturnal migrants. That blue arrow is actually the arithmetic mean, which I thought was kind of interesting, so I left it in there. Males did not leave at a different time than females. And Salt Plains birds also left at similar times as Texas birds. But New Mexico birds left randomly throughout the day. There was also a smaller sample size there, but overall, no significant departure time for birds in New Mexico. For departure dates, on average, a bird left on migration July 29th. The range of departures was from June 1st to November 20th. And there was no variation between site and sex. So this figure here shows a lot of overlap between sex on the bottom here and site. So these birds roughly left at the same time, regardless of sex or site. The results of my regression indicated wind speed was negatively correlated with departure, the occurrence of a departure, and that a longer photo period was associated with the likelihood of a departure. So time closer to the summer solstice, when the days are longest, is a little, birds are selecting for these longer days. That's all I have for results. As far as discussion goes, in Texas and New Mexico, declines are definitely happening, but the big question is why and what can we do about it? That's the ultimate goal. And studies have been done, actually by Dr. Conway's grad students, showing elevated levels of selenium in blood samples and ubiquitous mercury in all samples, not above biological thresholds, but these levels are potentially concerning. We don't know exactly how they're affecting these birds. if they are at all. We have documented increased nest predation. This was from 1998 to 2009. So I didn't look at nest predation, in my study, but it has been shown to have increased. Also, we have documented decreased survival of snowy plovers, again, for the same time period. And we have documented decreased surface water availability. So these springs in Texas especially are drying up. And to top it all off, we have these severe weather events happening. So hurricanes are actually occurring on their winter grounds. Heavy hail in this area. I think we've all experienced the hail in Texas. This can actually kill birds. It can destroy their nests. I've actually seen this firsthand. And we have these heavy precipitation events that just wash away their nests and can be actually fatal to the adult. So they're getting hit on all sides, it seems like. This is in New Mexico. Again, these are the mean survey counts with standard error bars. And what I want to focus on is these periods between survey events of really sharp declines. These are acute declines from one year to another that I think might indicate something's happening during the winter. So again, this is New Mexico here on the left. You've got Texas on the right. And again, we have these severe acute declines between survey events. And it was proposed in a study about 10 years ago. And I think it might have something to it, that these declines could be happening because of hurricanes hitting their wintering grounds. So we have Hurricane Harvey hit in 2017. This was in August, I think August 17th. A week before that, we had a snowy plover detected in Rockport at that tower. This was a Salt Plains bird, but this is known wintering grounds for Texas birds too. We know this because of re-sites. So hurricanes like Harvey, these really severe events, could be causing mortalities on the coast, and fewer birds would come back. There were 4 severe hurricanes hit all the way from the Yucatan Peninsula to Louisiana in 2007. And again, we don't know where bitter lake birds go in the winter, but and probably none of you have heard of Hurricane John, but it hit the Pacific coast of Mexico, Baja. It kind of ran up along the coast. And if snowy plovers winter there that are from Bitter Lake, it's possible that this hurricane really hammered them. This is just in theory, but if they go there, which is, one of the areas they might migrate to, these hurricanes on the Pacific coast also might be affecting them. And before I move on, what I think is happening is these severe weather events that have always been occurring are knocking down their survival, knocking down their abundance. And because of all this other habitat degradation, they're not able to recover as they might have previously. In Salt Plains, we have this very large population of roughly 5,000 individuals. That is likely holding steady, at least in that time period from 2007 to 2017. And we have this high detectability, which might indicate we could have larger search areas. We could be surveying these areas with just one person. There's some implications to this high detectability as far as survey methods go. And I think it really validated these annual surveys done from 2013 to 2017, that those snowy plovers that they saw, they didn't miss very many. Salt Plains at roughly 5,000 individuals is the second largest population in North America. But I wanted to point out that it is actually the highest concentration of snowy plovers in North America. Salt Plains is a much smaller area than Great Salt Lake. And with these overlapping confidence intervals, these populations might actually be comparable. But regardless, Salt Plains has hemispheric significance and might exist as an important pool of individuals for surrounding populations. and also maybe as an important pool of genetic diversity for surrounding populations. So I've talked mostly about population trends. Connectivity, before I get into it, I wanted to talk about why it's important. And it brings this theory of metapopulation dynamics into the mix. So Richard Levins in 1969 coined the term metapopulation dynamics and essentially called it a population of populations. So all these populations where connectivity between them is a crucial component. And connectivity influences population dynamics and the way these communities respond to changes in the environment, like climate change and habitat degradation. And it gets out this probability of persistence. So can these populations persist into the future? And connectivity is an important component of that. In Texas, we had high connectivity between these lakes, but maybe not so much to lakes that have dried up, which isn't shocking, but it sort of reinforces this idea that we're losing habitat for snowy plovers in Texas, at least. We have maybe weak connectivity between Oklahoma and Texas, but again, I think this was a migration movement. I really don't think we've got a lot of birds mixing from Oklahoma and Texas, at least breeding adults. We have some weak connectivity between New Mexico and Texas. So 2 individuals moved from New Mexico to Texas. One went back immediately and one disappeared. So we didn't have examples of those birds using that habitat, but they did appear to know where it is, and they flew there for a particular reason. We had no connectivity between Oklahoma and New Mexico, again. This may just be a distance component. They're definitely the farthest apart. And my proposed or suggested population connectivity is Oklahoma as sort of its own isolated population, regardless of how big it is. We really didn't get any examples of breeding adults moving to New Mexico or Texas. But I think we still have some support to think that Texas and New Mexico might be its own metapopulation. And if we do model it in the future, we should keep that in mind. We know that Texas birds from resites move to the Gulf Coast of Mexico during migration. We didn't get any detections on the coast in my study of Texas birds, but we have historical resites. We have strong evidence that salt plains birds go to the Texas coast and Louisiana. And we still don't know where New Mexico birds go during the winter. And this, in light of these 60% declines, is a really important piece of the puzzle. These birds might be declining because of their winter habitat, but if we don't know where that is, we can't do anything about it. So overall, we have this large, apparently stable population at salt plains, which might represent an important pool of individuals and genetic diversity for the region. But my studies seem to show that there's low connectivity between this big population and these smaller ones in Texas and New Mexico. One thing that we didn't look at, and is very hard to look at, I'm not sure we could pull it off even if we tried, is looking at juvenile dispersal. So juveniles are historically, they're the ones that do the dispersing. If you have a really large population, these juveniles will go off and look for available habitat. But evidence from resites, again, showed that these juveniles are generally highly philopatric, or they show high site fidelity. They go back to their natal sites. So whenever we do resite them, they're back where they were born. The same lake, same region. So we don't have any evidence yet, but resites are really few and far between. Just because we haven't resited them, dispersing doesn't mean it's not happening. And getting at juvenile dispersal really is important when looking at recruitment, which has a really strong impact on the probability of persistence of a population. So are these juveniles growing up to be reproductive adults? If they don't, then nest success doesn't really tell you anything. So this could be a big piece of the puzzle that we're missing. Overall, in light of declines, in light of the connectivity or the disconnectivity that I've shown, what's the conservation concern? We're looking at potential extirpation of birds at Bitter Lake, I think. And if the remaining springs dry up in Texas, potentially those populations as well. Also, as far as ramifications of extirpation, unpublished data suggests that Texas populations might represent this really important pool of genetic diversity. So they use this metric called allelic richness, which is a measure of how much genetic material a population has to work with. And the more it has to work with, the better at responding to, habitat degradation, strong weather events, killing off a bunch of birds, that kind of thing. It's more adaptable if it has a higher allelic richness. And losing this high diversity might have ramifications for surrounding populations, like New Mexico. It might represent a loss of adaptability. A little further, talking about Lake B might represent superior habitat in Texas and New Mexico. It represented 53% of the movements made to a lake. But again, most of those movements or a good chunk of those movements were made by 2 individuals. But even disregarding those 2 individuals, still more birds moved to Lake B than others. And this might help us focus habitat management. This is a privately owned lake, so there's logistical issues there, but just knowing that it represents really important habitat, it's got good, consistent springs throughout the season. It's a large lake that's in the middle of all these other lakes. Regardless of the reason, it might be important to maintain that habitat quality. I think when considering population dynamic models, it's important that we think about separating salt plains from Texas and New Mexico. If we include individuals coming from salt plains into these models, if we show connectivity, it might give us the wrong idea of the persistence of these populations. If they're more isolated, they might not, we might want to model them thus so that we get a better idea of what's going on. And lastly, talking about migration timing and phenology. So what I found was that snowy plovers might actually be nocturnal migrants. And when we're talking about wind turbines and mitigating their potential effects, knowing when these birds depart on migration might be important. Wind turbines are everywhere now. I know they're south of Lake A. I know they're south of salt plains. Pretty soon they're going to be in our backyards. So knowing details about their migration might help us mitigate the effects of these wind turbines. To date, I don't know of any actual studies showing that they negatively impact plovers at all. Not in terms of migration anyway. So, this is a null point at this point, but it might actually prove important in the future. And when monitoring changes in migration phenology in response to climate change, having baseline data for when they migrate and seeing if they change in 10, 20 years might be really important. Like they're migrating way earlier now. We've proven it, this is occurring. So this data gets at that baseline. In the future, and after doing this research, I'd really like to see some annual life cycle monitoring snowy plovers. And by that I mean we need to know where they go during the winter. And in conjunction with that, I think it's important to look at winter survival to see, are these birds, is their winter survival going down? Is it really low to begin with? What's going on? And in relation to connectivity, I think it'd be really interesting and potentially important to look at the genetic underpinnings. Are these birds genetically isolated? Again, that can get at population persistence, their ability to adapt. I think more rigorous monitoring of New Mexico is important as well in light of these shark declines, and potentially looking at a population viability analysis, so gathering the data to do one of those. And lastly, and again, I talked about this earlier, looking at a closer monitoring of juvenile dispersal. This is really, really hard to do. It's hard to target and catch a juvenile. A nestling you can just run and pick up, but a juvenile can fly. So that has logistical issues, but I think it could prove to be a critical component of connectivity. That's all I have for today. I want to thank any students, technicians, my committee, anyone who helped gather data, especially help put up towers, all the guys at Salt Plains that helped me put up towers and helped my technicians there. At Bitter Lake, you guys that helped me put up towers, et cetera. I got a lot of help doing this stuff, and I'm really appreciative. Thank you for all the financial assistance, and that's all I have for today. Thank you. Yep.
If you're trying to figure out where some of them winter, start this.
So the question is, if I'm trying to find out where they winter, where do I start? My tags that I've been using, they die after 6 months or so, roughly. What you need is a tag that can consistently detect them over long periods of time, like satellite tags or store on board GPS tags, which are more expensive, they're heavier. There's only so heavy you can go with the tag. You know, there's a threshold that you have to stand under. So really it's, you know, they're also more expensive. So it's getting that technology right and it being more affordable, et cetera. But we can tag them with better tags that can monitor them constantly, which would be, I think, really the answer. Some guys from Europe are looking at Central America and Mexico, snowy plovers, and they're using GPS store on board tags, but you have to catch them again and take that tag off. So again, logistical problems. My recatch is actually really low, so I wish them luck, but I don't know if that's gonna work. I don't know. So.
Yeah. In terms of connectivity, you have the Oklahoma and Texas population.
Yes,
right?
yeah.
But you also have these strong arrows pointing them both to the same coast.
Yes.
Big area.
Right.
Can you talk a little bit about
why
they're not connected?
Contribute to. Yeah, so the question is, since they both winter on similar areas, why isn't the connection, why aren't we seeing connectivity there? And I think that's definitely a possibility. We do, still in light of that, we haven't gotten resites of Salt Plains plovers in Texas. So even if they do mix there, they aren't necessarily breeding there. We're also not, they do some pretty consistent surveys, breeding season surveys on the coast at certain refuges especially, and we're not seeing our birds breeding there. We have one bird from Salt Plains that was resighted nesting at Matagorda Bay. So, you know, it bred in Salt Plains, which is how we caught it, and then it bred again on the coast. So there is definitely the possibility of that. Right now we don't have resite evidence to back it up. It's kind of the problem. But that's another avenue, definitely, of them breeding on the coast and maybe dispersing later.
Any other questions?
Sure.
Thinking about
Mm-hmm.
What's the furthest south?
The furthest south Modus Tower on the coast is actually in Brownsville. So it stops. There are none on the Mexican coast on either side. I don't know if we even get people surveying or resiting on the Mexican coast. So we have this big black hole, of information. So they might also actually winter in southeast New Mexico. There's potash ponds there that they might hang out at. But again, we have no resites. We have no data from their wintering grounds. Yes. Yeah. Yes. So the question is time and photo period are temperature are correlated. I didn't try not including one or the other in the model. I did look for multicollinearity, and those big numbers indicated that they weren't as correlated as you might think. So I went from that, the variance inflation factor or whatever, VIF, indicated that I should leave it in. So I did.
Yeah, how long does snowy plover?
Typically, on average, they'll live 2 to 3 years. They can live as, I think the oldest known snowy plover is I read recently that they're 2 to 3 years. Dr. Conway's indicating that they're older, lived maybe 5 years. Right. So they can live up to 10, 15 years, I think is farthest range. But some data from probably other populations indicate they're, a little shorter lived than that. They breed in their second year. So they are born and the next year they can breed. So they get going pretty quickly and can reproduce and contribute, even if they are short-lived.
You stated Lake V was pretty important next to Bushwood.
Right. So the question is, if Lake B is important, what kind of habitat there are we looking at to maintain? Or, yeah, so the springs there are consistent throughout the year. They don't, well, they do now a little bit. They don't really run cattle there, so you don't get the trampling of livestock that occurs in some of these nests, some of these lakes. I don't notice salt cedar there as much. At Lake A, that was really important. You guys got rid of some salt cedar there, and the spring actually, I think, anecdotally, I think doubled in size from one year to another. But for whatever reason, I think these consistent springs are really important there. It's possible that there's less irrigation pumping to some degree surrounding that lake. I know that can contribute to spring flow. So maybe mitigating that or looking at that. Right now, that's all I can think of. Really that spring flow, the constant spring flow, and just it being really big and in the middle, I think contributes to why snowy plovers select for it, potentially.
Are the landowners invested in keeping the plovers
Yeah, so the question is, are the landowners invested in keeping these snowy plover populations healthy? From my interactions with them, they are positively interested in snowy plovers. You talk about them, they're curious, they want to know more about them. I don't know how much that interest and goodwill goes towards reducing some of their other practices, but I think it's there, and I think we can definitely cultivate it and support it if you go about it the right way, essentially.
Go back and do it.
Yeah. Giving them the results of my research is a big one. I've sent project updates to them before, and they'll respond and be interested, and they like that sort of thing. I think that's really important to let them know what we're doing on their lands. Why did I put these towers up? They probably think it's really weird, but seeing the results of this research could I think really positively impact them. Anybody else?
Thank you, everybody, for coming.
All right. Thank you, guys.